Hi, folks. Can you hear me?
Yes.
Okay. On behalf of the Technical Track Committee at Women Transforming Technology, I'm super excited to introduce the topic of one universal language for all machine learning models by Anna Jung. Deep learning is used across multiple industries to solve difficult problems like natural language processing and computer vision. With the help of deep learning frameworks like Tensorflow and PyTorch, machine learning engineers can quickly build complex models like a virtual assistant to recognize speech without being an expert in machine learning. However, one of the biggest challenges in the field is choosing the right framework for your scenario. And with no interoperability across frameworks, engineers often find themselves locked into a specific vendor limited to initially selected frameworks capabilities. With Open Neural Network Exchange, ONNX, machine learning engineers no longer have to worry about limitations. They can pick and choose the tools that they need to build their model by leveraging the ONNX open format. So ONNX is a universal language, an open format built to represent ML models through a common set of operators in a common file format to enable ML engineers to make better, faster, and smarter models without being locked down into an ecosystem. So in this session, Anna Jung will explore in detail what ONNX is, why it matters, and how you can get involved with the project. Anna Jung is an ML open source engineer at VMware, contributing to various open source projects related to machine learning, and is passionate about giving back to the open source community and increasing openness in the machine learning field. When away from the keyboard, Anna is often at film festivals supporting independent filmmakers. Over to Anna.
Thank you, Mamta. That was a great introduction. Hi, everyone. My name is Anna Jung, and today I'm going to talk about one universal language for all machine learning models. So we'll start off with a quick introduction to deep learning and its challenges, and talk about an open source project called Open Neural Network Exchange and why that project matters. So let's start with what is deep learning. So in a very high level, deep learning is one of the ways that machines learn, and it's inspired by the human brain and how we human beings learn. And naturally, like the brain is key to intelligence. So deep learning actually mimics that to help create intelligent systems. And what makes deep learning so special is that it's able to identify important features of data on its own and able to handle big unstructured data to solve complex problems that was not really possible with like traditional machine learning algorithms. So one of the example of a complex problem that deep learning solves is speech recognition. Speech recognition is the process of interpreting human speech into a format that a computer understands. And the main goal of speech recognition is to make it efficient for humans to communicate with computers. However, as we all know, human-to-human communication is not perfect. We're always constantly running into communication problems. And this is hard when communication is done through text versus sound, and even harder when you're speaking to someone face-to-face versus without seeing their facial expression. In human communication, we actually communicate not just by words, right? Other things matter like tone, body language, accents, speaking styles, like all these things become a really important factor on how we communicate. And that's why language is really hard in real life, but it's also really hard in computer science. And that is why speech recognition is one of the complex problems that requires deep learning, because it's able to scale and perform effectively with more data that is required to understand human speech. So now that we know what deep learning is, let's look at how it relates to machine learning and artificial intelligence. So deep learning is actually a subset of machine learning, which is a subset of artificial intelligence. Deep learning imitates the working of human brain, as mentioned before. And then on top of that, there is machine learning, which provides system with ability to learn without being explicitly programmed. And then there's artificial intelligence on top of that, which is machine that displays human intelligence. So taking the example of speech recognition is commonly used in virtual assistants like Siri, Google, and Alexa. And virtual assistants are systems that are powered by artificial intelligence, specifically powered by machine learning algorithms, one of them being the speech recognition that leverages the deep learning. So I know this is like really high level, but I hope it does give you a better understanding of what deep learning is. And now let's actually talk about some of the challenges of deep learning. So there are actually quite a few challenges in deep learning. I think the really famous one, not just in deep learning, but just any models in general, is the quality of data, right? The famous saying, garbage in, garbage out. And there's also another famous one where there's lack of transparency in learning called the black box problem, because deep learning, it has a lot of like layers, hidden layers, you call it. And then sometimes it's really hard to understand what learning goes on each layers, making it really hard to explain why model like predicted something like A or versus B. But with deep learning, there are a few challenges that you run into like right away when you're creating the model before you get to that understanding the model step. And some are actually listed here. So like too many frameworks and no interoperability, environment mismatch, optimization, and vendor lock-in. So to understand the problems better, let's actually take a look at how deep learning model is created so that it gives us a better idea of where these problems come from. So this is an example of end-to-end workflow of creating a model. So a model, for those who are not aware what that is, it's actually just like, think of it as a file that's been trained with specific data to recognize a specific pattern. And this is how you would create that. And this end-to-end workflow actually doesn't really do a lot of justice because it does, there's a lot of steps that goes beyond this where it's not really like, you can't really show it in a graph. So, but I did wanted to give you this basic idea because I'm actually going to use this, the extremely simplified end-to-end workflow for this talk so that it's easier to remember for everyone. So in a very high level, these are the steps that it will take to create a machine learning model. First being the gather data, prepare data, train model, test model, deploy model, and then improve. So now let's use this to talk about some of the problems you run into when building a deep learning model. So the first problem that you might run into during during the train models process. And during that step, you might see that there's too many frameworks to choose from. And just to help understand what a framework is just a tool that allows us to build deep learning models easily without getting into all the underlying algorithms. So like a really popular deep learning framework would be like Tensorflow, like PyTorch and Keras. So going back to the frameworks, you might think that having all these choices might actually be better, but the choice of framework becomes extremely important because it can have a direct impact to the performance or stability of your model based on your use case. So some frameworks are actually optimized for specific characteristics like fast training. And when you're experimenting locally, you might not really care about that because you're probably working with a very small subset of data. But then like later, when you decide that you do want to leverage this other framework, you might actually run into a problem because moving from one framework to another is not an easy task. It actually takes a lot of effort to convert model between frameworks. And worst case, you might have to retrain everything from the beginning. So early decisions could have a big impact later on. Another problem that you run into is that model requires different optimization between training and inferencing because they require different compute resources, and optimization can take actually a long time. And if you deploy the model in different environments like cloud or edge, you might have to optimize per environment, which really slows down your like deploying a training model to production. And finally, you might run into a problem where improvement actually to the model can be made because there's a strong dependency between the framework, software, and hardware for training and deployment. And you might end up being like locked into a vendor and might not have the freedom to easily transfer to different environments or hardware. So, but I think the biggest problem of all in deep learning is that there's no standard across AI. And all the problem that I mentioned just before really points out this problem. And right now, there's a very fast growth in AI in deep learning. And this was actually mentioned during the keynote this morning by Carol. And with fast growth in this field, we have too many tools, and that is siloed without thinking too much about the end user. And every company is coming up with these tools, different tools and different dependencies, and it's getting to a point where it's making it really hard for engineers to develop and deploy the models that we want to create. So this is where Onyx comes in to solve all these problems. So Onyx, or Open Neural Network Exchange, is an open format to represent machine learning models, focusing on framework interoperability and shared optimization. So basically, you can think of it as a format for all models, no matter what framework it used, where it was trained, and what dependency it has. You can represent it in a model. You can represent a model in a standard, like in Onyx format. So the idea of Onyx came from Facebook and Microsoft back in 2017. And it was created because they noticed the same problem where AI ecosystem is becoming this really big mess where people wanted the flexibility of having the models to communicate with each other, but didn't have a way to do it. And the goal of Onyx started with just one simple mindset, which is make tools work together. And after the announcement of Onyx, other companies like Amazon, Intel, NVIDIA, IBM, they all started contributing and supporting Onyx in favor of this open standard. So with the goal of making tools work together, there are two main benefits of Onyx. First one is to provide interoperability between frameworks. So with Onyx, your model now becomes portable and reusable between frameworks. You can export the model in Onyx to leverage in a different framework, and that supports the concept of transfer learning. And then what you now have is actually a separation of concern between training and inferencing, because you can use any framework to complete both tasks. The second benefit of Onyx is hardware optimization. So by leveraging Onyx, you can easily access hardware acceleration using ONNX compatible runtimes and library to maximize performance. So with ONNX, you can move the model across the hardware without needing to re-optimize the model. So this means that you develop once and deploy anywhere without losing accuracy or performance of the model. So now let's take a deeper dive into what ONNX format looks like. So underneath, ONNX is just a protobuf file format. And protobuf file format was something developed by Google with the goal to provide better way to make systems communicate. And in this protobuf file format, it contains definition of computational graph, definition of standard data types, and definition of operators. So I provided a small computational graph right here in the middle, just to help you visualize it. And computational graph is just like node corresponds to a math operation. It expresses the way to evaluate an expression. So in this example, there's two inputs and concatenation is one of the operators that's being used to produce an output. But you can think of it as simple as like having an addition there in the middle where input values are like 1 or 2, and then the addition will output 3 as the answer, as an output. And if you actually change that graph into a text format, that's what you get on the right side, where you can see the definition of the graph and definition of the node inputs and outputs. So basically, you can think of ONNX model as a bunch of nodes that makes a huge graph. And this format can be used to store, version, and control encode. So now that you know a little bit about ONNX and what it does, let's talk about why ONNX matters. Well, I think having a standard that gives you flexibility to focus on building model is a huge win. But what's really, really great about ONNX is that they embrace openness. So ONNX is an open source project, meaning the source code for ONNX is available to the public. And ONNX is open governance project, which means that its future is decided by the community member who are voted by the community. And there's no one company that determines the future of the project. And ONNX is an open community project, which means that anyone interested in the project can get involved and help improve the project for better use. And with all that together, ONNX promotes open AI ecosystem, makes it easier for all tools to work together, which will allow everyone else to build better models that can run anywhere. So to wrap up, if you remember anything from this talk, I hope it's these 4 things. Open Neural Network Exchange, ONNX for short, is an open format that represents machine learning models. I didn't really talk about this, but it does actually support both traditional and deep learning models, so it does support all models. ONNX is a universal language for all models. And with ONNX, you can build better models using any tool that runs anywhere. And lastly, if you're interested in learning more about ONNX, you can become part of the community and join the ONNX journey at github.com/ONNX. Thank you.
Thank you, Anna. That was really amazing. I'm handing over to Jody for the next session.
Thank you so much, Mamta. Great job. That was an awesome technical track. Thank you. Welcome, everybody. Good afternoon and evening to all of you across the world that are joining us today. We're really happy for you to be here with us today. My name is Jody Sheely, and I'm a partner solution architect and a VMware principal in the office of the CTO for the global field. I've worked at VMware 9 years, and I'm really happy to be here with you today. Today, I'm happy to help moderate this technical track with Divya Mukhopadhyay. She is an awesome speaker, and I'm really excited to be on here with her today. This session is about account takeover, attack, its detection, and relevance. Divya is a data scientist at Workday with a special focus in security and privacy. Divya also really has a passion for work-life balance, and she's an avid runner. I worked on the Transforming Technology Technical Committee that helped decide why we selected Divya's technical session. I personally really liked the account takeover attack track because it caught my ear with her view on how to create better situational awareness around fraud and account takeover. With no further ado, Divya, the floor is all yours.
Hi, thanks, Jody, for that awesome introduction. Let me share my screen. Okay, so I guess, can you see my slides? Wow, thank you, thank you, slide, awesome. Just 1 minute, let me go to the first slide and start presenting. Okay, can you all see my slides?
Looks great.
Okay, so I'm going to talk about the account takeover attack and how it's relevant in today's world and how some of them can be detected. I'm sure there's a wide plethora of them. We're going to talk about some of them. So what is an account takeover? It's a form of identity theft where the attacker successfully gets your information, like username, password online, like your information online, which means a username, a password, your email address, password, or any of these credentials to break into your account and target something that is of monetary value. It can be your paycheck, it can be your stocks, it can be your flight miles, it can be your Macy's account where they use your credit card to order something. It can be anything. And like I was saying, it can be in any number of industries. It can be in the financial industry where they can steal your funds, tamper with your portfolio, read out paychecks. If it was a payroll, like get the paychecks to from your account to their account. So at the end of the month, you won't get a paycheck, that hacker will get a paycheck. Access to retail accounts in case of shopping or retail, say Macy's, eBay, you name any of the retail accounts. We have all like 100 different accounts today. For anything and everything, we have a separate account, right? So any of these accounts, if you save a credit card and if they can get access to the account, they can use it to buy something, they can use it to sell something on your behalf if it's like a platform like eBay, or if it's a mileage account like frequent flyer miles, they can get your miles, book tickets, and so on. I'm primarily going to focus on payroll account and how some of those account takeovers happen. So let's run through a scenario how that can happen. So first of all, there are like accounts like PayPal today, like Workday. Workday has a lot of information about their tenants for payroll, HR, and all that. So if someone gets access to this customer payroll website, that can be PayPal, that can be Workday, that can be any bank. So if they target that and they run persistent campaigns by sending you emails or check how people necessarily log into them. Is it through an email? Is it through typing in the URL? Is it through like a Google search? And then launch an attack that will be the most effective. One of the ways being a phishing email, where they send you a fake login page and say something like, you have to log in here to change something because your account is at risk. Do this ASAP, otherwise something might happen. And some users, without checking if it is actually real, if the URL is actually correct, they would click on that fake login page, in that fake URL, that would lead them to a fake login page. Like here, you can see like this page looks exactly like PayPal, but it's not really PayPal. Or Barclays Bank, or this is one of the university accounts that they use, Canvas university accounts, where say teachers or students get paid. And they log in there, change your bank account information to their bank account information. So when the payday comes, the paycheck goes to their account and not your account. And one of the things about this kind of an attack is that mostly we are not paying attention. Like, is my account my account? Do you always go to your payroll account and check that? I don't. So by the time we realize it, it might be too late, because already 1 month has passed, or maybe one pay cycle has passed, and you have probably lost some money. So it's pretty severe of a situation. One of the phishing site and email that we have as an example in Workday is this one. There's nothing to do with Workday in general, but this is just an example that we built in our team. So you can get an email like this, dear Workday user, this notification messages will let you to know that we detected some errors in your account and so on. And they send this link for you to click. And you would see that in these emails, normally there would be grammatical mistakes. Like you see here, account, the O is replaced with 0. So there are some things that stand out in emails like this if you pay attention. And then once you click the link, they would go to a page that looks very similar to the parent page. And if you enter your credentials, yeah, by that time it's already compromised. So how do we identify them? I mean, one of the things I spoke about that, okay, yeah, if you are careful, you would not click the URL. If you are careful, you would check that email doesn't look like a legitimate email. And if I have to do something, I will not click that email. I would type it on my browser, or I would go to my saved pages and go from there rather than from the email. But say all said and done, you do it. From the perspective of a mitigator, we are looking at it from the background, say for our tenants as Workday security team, as a person in the security team, data scientist in the security team, we can get a lot of data for every click that someone makes. So how do we identify them being on the other side of the attack, like being on Workday's side, for instance? We have data, as we say, we have access logs that we can detect. We can detect ATOs from. And that can range from like the type of tasks someone is doing. So for instance, you always log into your Workday account and you check orgs, or you check a certain person, or you check your pay stub, or apply for a PTO or something like that. But you would not really change your bank account every day. So depending on the type of tasks someone is doing after logging into someone's account, that's an indicator. Another thing can be known or bad IP addresses. In the security community today, we have like a published list of IP addresses and ASNs that are circulated that are already known to be bad. So if something is coming from these things, these sites, it's already a red flag that, okay, something is going on. This is not good. And like the type of tasks behavior, there can be other anomalous behavior patterns, like a lot of logins from different parts of the world, or login at a time which the user should normally not log in. Things like that, anomalous behavior patterns can also be a signal that this is not a legitimate user. And the way right now people manually or like have been doing it, or historically have been detecting ATOs, are using these logs, and they have a set of rules that, okay, if a bad IP address is found, block it. If this doesn't look like someone's behavior, first of all, behavior analysis or recognition is a very difficult task. It's not always a pattern. It has to be like a time series analysis. So it's already hard as it is to recognize that. But even if you do it with just business rules, it's not enough. So what happens is that every script kind of finds violations and then takes an action at the end of the script. But we don't know that if these rules were actually correct. Like, what if this was actually an actual user you blocked? That is not good for, say, Workday as a company. We don't want to block our legitimate users from doing their work on their account. And second thing, the output files, these files that you get from these logs, they are really huge, because think about it, every time you make a change, click something, do anything on the website, there is a log for it. So filtering them and making sense of the data is quite some task. It's a pretty hefty task. So these files are pretty big to be analyzed. So, and again, like I said, just because rules are violated doesn't mean that it's a fraud. There can be like false positives that we think that, okay, it is a fraud, but it's actually not a fraud. So we need to make sure that we have a good balance of how many times we are getting false positives and how many times we're blocking a legitimate user. So that's why we look at machine learning, if that's a better way of solving this situation or this problem here. Why so? Because one thing is access logs are big, and not to say that machine learning has a better way of handling big data sets, but we have ways of training the model so that it doesn't always have to look at huge data on real time to make a decision. It can look at a very thin sliver of data in real time to make a decision depending on how it was trained in the background. Second thing is, right now the detection methods are really manual and time intensive. Say you run a query or you run a rules engine and so on. That goes on, looks into the entire data set and makes a gives you a result, which are really time intensive. If we can have an automated system that grows with time, because these rules can evolve with time, right? Today we have a rule, tomorrow it can be something else. The attackers keep on updating their ways of attacking companies and sites. So we need to grow with time, and rules engine cannot do that. Machine learning is a much better way of going to solve that problem. So how do we really detect them? So I spoke about the machine learning model, but what does, like, how is a model really built? What fuels a model? They are actually features. So, and some of the features, some of the noteworthy features, I'm sure there's a lot of other features that we use, but these are some of the noteworthy features that I wanted to mention. That session novelty features. Like, for instance, if the user is logging in from a new city, new IP address, new subnet, or time of login, like does the user normally log in at this time? If the user, say, is in Pacific time zone, they should not be logging in Asia time zone, right? Like in London time zone or like India time zone. If they're doing it, it is an anomalous behavior. That is not to say that that user is bad, but it's something that raises a flag. Then user history anomaly features. For instance, like how far the user's login locations have been in the past. They have worked from Mountain View and then Pleasanton being their office. Say, for instance, those are the only two places. But now all of a sudden you see that user is logging in from another part of the world and then again from Bay Area. So those are pretty different things than what the machine has seen historically for this particular user. Again, normally we always use the same browser or the same one or two browsers. We rotate them while we are signing into our payroll account or any account. So if all of a sudden you see a new browser that has been used for logging into Workday or any other account, that also can raise some flags. And finally, there are some user dossier features, which are mainly to put into context the user's own behavior, like how many number of fraudulent sessions he has had in the past 6 months. Maybe this user normally works in a way which looks like it's fraudulent, but it's actually not fraudulent. Or how many number of cities he normally logs in from. Say, for instance, I log in from a lot of cities because I travel a lot, versus another user, they don't travel much. So maybe they have logged in from 3 different cities in an entire year. So we can normalize that for every particular user depending on their own behavior. So these features help with those things. Finally, we use the XGBoost model as the choice of algorithm for detecting ATO. And I'm sure there are better models, and we can use it. We can use neural nets and time series detection for doing it. But XGBoost being such an elegant method that it helped us solve the problem with very less effort. And why so? Because XGBoost helps us with disbalanced data. Because right now, today, you would not expect someone to have a lot of true positives, right? Like you would not have a lot of ATO cases happening in your company. That hopefully is not the case. So you would have very small sliver of data that you have for training the model to learn what it looks like for actual fraudulent scenario. In that situation, this kind of an algorithm helps with the model learning, even if the data is very disbalanced. There is only probably 10% of the data or 5% of the data is positive, 95% of the data is negative, but it still learns the pattern much better way compared to like random forest or gradient boosted models. And we can go more into why XGBoost, but I wanted to just leave it here. If you guys have any other questions, you can always ask me, text me on the Whova app. And finally, key takeaways. So if you remember anything from this talk, as a user, always remember to check your phishing emails. Like if an email looks something that stands out, always trust your gut. check for it, like check the URL, and have multi-factor authentication set up for most of your accounts that are sensitive. And I think most of the platforms today allow to do that. Like either you have CAPTCHAs or you have, like you can get it through your phone, like you need a code through your phone to authenticate, or maybe a physical key that you need to authenticate with. So always have that kind of a setup ready for your sensitive accounts like banks, payroll, any of these things. And as a mitigator, always remember that the devil is in the data. So if you look into the logs and multiple logs, not only access logs, there can be multiple logs, network log, access logs. I'm sure you can figure out things proactively than reactively, so that tenants or customers don't have to suffer, and we can catch these at the very beginning and stop those sessions from happening. That's it. Thank you.
Hi, Divya. So thank you so much for presenting. I think we might have time for maybe 1 or 2 quick questions if anybody has any questions. Otherwise, we can always create a breakout room and go over there and take the conversation further. So I'll wait a second, give everybody a minute to see if they have any questions. That was really awesome and very informational, by the way.
Thank you. Yeah, it's a really interesting topic to talk about.
I don't see anything in the chat. Okay, well then with no further ado, I'll hand it over to you, Karina, for the next session. Bye, everybody. Thank you for joining.
Thank you, Yeri. So hello, everyone. Thank you for continuing with us in this session. I'm Karina Caro. I'm an assistant professor at the Autonomous University of Baja California in Ensenada, Mexico. I was part of the technical track committee for the conference, and the next talk of the session is a thin line between love and K8s. We were very excited for this talk because Kubernetes is a hot topic and an amazing open source tool that can possibly transform a business and its IT outcomes. So it is my pleasure to introduce 2 amazing experts of this topic. On this topic, Rachel Lekin. She is a Kubernetes field engineering in the Modern Application Business Unit at VMware, and Ramona Jackson, a product portfolio director supporting the Advanced Bottle Management System program at RISE 8. Welcome.
Hello, everyone, and welcome to A Thin Line Between Love and K8. If you do not know, A Thin Line Between Love and Hate was a 1996 rom-com that chronicled a young man's unfortunate run-in with a woman who was very attractive, but had some deep, dark secrets.
Excuse me, Rachel, can you change to the presentation? Oh, thank you.
Yes. So what we want to talk about today is kind of how Kubernetes is a little like that woman that he had a run-in with. Very sexy, it's a buzzword in the industry, but what we find is that once you actually get it into your environment and you put it in front of your developer and infrastructure community, it may or may not be what you thought it was. So as Karina said, my name is Ramona Jackson. I'm the Director of Product Practice for RISE 8 and a former VMware employee in the MapBU business unit, where Rachel Lekin is currently. And I have my LinkedIn information there, but my Twitter is too hot for cable, so it's not shared. Rachel?
Thanks, Ramona. Yes, I'm Rachel Lekin, and I'm a senior solutions architect now. I've moved roles recently. I'm currently at VMware, and I was formerly an IBMer as well. You can find me on LinkedIn, and my Twitter is not too hot. It's quite boring, so you can follow me there as well. So before we kick off the topic, I want to set some context around the differences between containers and VMs, right? So you probably heard this kind of conversation before, like with customers, or if your developers are talking about, should we go with containers or VMs? So I just wanted to set some context. So containers are emerging practices, right? They're newer, they're based off of microservices, they are lightweight, they start up very quickly, and they require less resources. On the other hand, VMs are more traditional in their approach. They're more associated with monolithic applications. They require large OS images. It takes minutes to start up. And of course, they're more resource intensive. The pro of containers is that it has a very, what do you call it? A very quick approach to get customers going. But one of the cons is that with this quick approach, the ecosystem is still evolving. So you're not going to have as much support out in the community. On the other hand, VMs are more established, so you'll have more robust support from the larger ecosystem. And when we talk about containers, there are a lot of different container types or solutions. In this case, we're going to talk about containers in the sense of Kubernetes and how Kubernetes orchestrates these containers, because that's what Kubernetes is. It's actually a container orchestrator. So why Kubernetes? Well, Kubernetes is this big, vast thing, right? You probably hear that a lot. But what happens, the one important thing I would say out of Kubernetes is its control loop algorithm. So you can go out and GitHub, as you know, Kubernetes is open source. You can go out and check out the code yourself. So I always suggest people to go check out this control loop algorithm that it has, which is basically what it's trying to do is you as a developer, system admin, whatever persona, you're trying to reach a desired state. So you will give Kubernetes your desired state, and then Kubernetes will try to constantly get to that desired state. So it checks the current state and says, hey, it's not at my desired state, I'm going to adjust. And then it checks it again, and then it checks it again, right? And if it is at its desired state, it's fine. It just keeps looking for it just to make sure nothing goes wrong. Another key component of Kubernetes is that it has an extendable API system. So what do I mean by that? As you can see in that picture is from the Cloud Native Cloud Foundation website, which shows basically the landscape of all of these great tools, cloud native tools that can connect with Kubernetes. It actually makes Kubernetes more robust when you actually use these platforms. So for example, if you have a customer that's trying to do monitoring of their infrastructure, there is one of these tiles here has a monitoring solution for your customer. And it's not just one, it's maybe 4, 5, 6 solutions out there that your customer will have. So that's really what makes Kubernetes great and flexible for your customers. Now, where is Kubernetes? I get this a lot from customers. Kubernetes I've heard described as infrastructure plus plus, PaaS minus minus. It's really a thin layer between both infrastructure and application. So what does that mean for your developers and your operators or system admins? So I look at it as it empowers your developers, right? So now they don't have to reach so far into infrastructure to get their applications running. However, from an operator standpoint or a system admin standpoint, they could view it as a barrier to applications because now it blocks them from having direct access to the applications. And this conflict is also kind of a love-hate relationship of itself. And that's where we see customers battling to install that thin layer of Kubernetes. And we also see in the next case coming up that this thin layer was not actually good for the customer and their use case. So I'll pass it over to Ramona to take us through the customer case.
When we think about Kubernetes, you often think about it as a part of a digital enterprise transformation strategy. So everyone's looking to take something old and make it new, to be able to open up new opportunities for their businesses and provide more value to their end users. But what most people don't understand that taking a more traditional or waterfall-like approach to transformation isn't always the way to win the race. And when you say Kubernetes, I often consider it one of the new 3-letter words or the new 4-letter words without the extra letter, meaning that it's something that's used all the time in the ecosystem, but not everyone really understands what it is. So when we talk about transformation, I like to describe it as we used to in VMware as a balance or a dichotomy between drivers and outcomes. So transformation looks very different depending upon the factors within your business ecosystem or your system of systems. Your drivers are most often surrounded around how you make revenue, how your expense picture looks, what your time to market looks like in comparison to your competitors, and then what your risk appetite is. And then from an outcomes perspective, it's centered around how you view agility, how you view mobility for your internal ecosystem and your end users, and then how you view security. Now, to kind of bring this into the picture, we want to look at an actual case study for a customer who said, hey, I've heard of Kubernetes, let me implement it. So while I was at VMware, I worked with a customer, Novant Health, very great customer, had a small IT footprint or DevSecOps footprint, but was looking to solve a problem where a lot of their commercial off-the-shelf stateless applications weren't working with their Tanzu application service or VM-based infrastructure or platform. So what they ran into when they looked at transformation through Kubernetes was first the resourcing challenge. Transformation takes people first and foremost, and it has to be the right people. They didn't necessarily have the necessary subject matter expertise within the Kubernetes space to be able to enable, train, and stand up the platform, or the platform plus infrastructure plus applications in a timely and effective manner. Process can be a vacuum. When you're dealing with a VM-based setup where there's a lot of developer experience, applications or tie-ins or plugins in your system, when you move to a Kubernetes setup, you have to think about how processes will change and what you'll need to provide to developers who may not be necessarily ready for that sort of transition. And planning for that can sometimes get in the way of your actual implementation. And lastly, it could be the right technology, but the wrong context. We love K8s, but not all the time that K8s loves us in the same sense of the thin line between love and hate movie. Where we are today as an organization and how we're set up from an organizational perspective, from a resourcing perspective, from a knowledge perspective, and where we'd like to be tomorrow must inform our decision to move to K8 or possibly to some other setup. So how do we choose with all of these factors? I think the biggest thing to look at is outcomes. We want to make sure that we're looking at how we are going to change behaviors internally to our organization and possibly how we might need to change behaviors externally with our end users. And the best way to look at those outcomes are with those three that we talked about before: agility, mobility, and security. Agility, of course, is how quickly we want to be able to move in response to change or challenges or even opportunities. Mobility allows for people to access apps and data in real time, whether that's for our internal workforce or our external end users. And then security includes the measures and systems designed to protect and safeguard our data and our information. So in order for us to be able to look at how these outcomes will change or delta plus or minus for organization, we have to understand what are the metrics, how is the way that we're going to measure our success for these outcomes if we make the move to Kubernetes. And I've listed here a couple of great metrics or measures to measure yourself against as an organization to decide whether or not Kubernetes is the right thing for you. Return on the investment, or ROI, is always one of the first things I ask organizations to think about or analyze. So if we make this investment in K8 and the extensible API ecosystem that will need to be added onto it to make it productionalized, what will that look like for us from a revenue and expense perspective? How will this affect our ability to deliver and the flow metrics that we have in place for our DevSecOps org? How will this affect the quality of the work that we're producing? What will change from our automation framework? How will the flow of features, outcomes, and so on and so forth be changed by introducing Kubernetes, as far as how we'll intake work, how we'll manage our innovation channel, and then how we'll productionalize and provide that to our end users? What will usage look like once we institute Kubernetes for our end users or our internal user base? Will this affect, from a security perspective, how we track known vulnerabilities and respond to those, or how severe those vulnerabilities will be now that we have a new security framework in place? And then how will we be able to recover from any instances where we may be vulnerable within this new framework? And the thing that I like to let people know when they're looking at these outcomes, they're deciding what measures to select is your current state What you have today in your arsenal drives transformation. So you're taking something old and you're making it new. But your future state, what you'd like to do, drives innovation. So this might be something that you've never done before, which is okay, but you still need to consider where you're trying to go from an outcome-based perspective, and then how you'll measure your success, because you don't know that you're successful unless you are able to measure how you got there. So to wrap it all up, we want to give you the TLDR, the too long didn't read, and I'll let Rachel go through the highlights from her portion of the presentation.
Thank you, Anna. So yeah, just to summarize, once again, containers and VMs both have a place in the IT system, right? But you have to understand what works for your situation, right? Back to what Ramona just said, what about your innovation and transformation? It all varies on your use case. Kubernetes is a declarative nature, right? It's always trying to find your desired state, and its ecosystem can propel enterprises into a love relationship if you take advantage of all of those API systems available to you as a customer. Kubernetes is also, once again, also a thin line between, pun intended, between both infrastructure and applications. And once again, you need to take advantage of the ecosystem in order for your developers and your sysadmins operators to be completely happy and in love with Kubernetes.
And to that point, it's important to understand that experimentation is the mother of transformation. You're not always going to get it right when you're looking to add to the Kubernetes ecosystem the right monitoring tools, the right deployment tools, the right CI/CD tooling and services. So you'll need to test and try things with your user base and determine what works best for your organization. Don't do it because everybody's doing it. Not everybody needs K8s in their environment to be successful and be able to deliver value to their end users. Some will thrive in a container-based setup. Others can stick with VMs, no problem, and still do very well. Know your drivers and your outcomes and measure them often. If you don't know why you're doing a thing and what that effect will have, what will be the effects on your enterprise and the outcomes or behaviors that you're looking to change internally within your org or with your end users, and measure those, then you won't know whether or not you've been successful. And lastly, remember, current state drives transformation. It informs the way that you will make things better or transform your digital enterprise. But your future state, the things that you want to do that you might have never done before, drives innovation. Totally okay to transform an existing container setup through Kubernetes or some other containerized based system. But if you've never done it before, you're looking at an innovative setup and you want to make sure that you have the right measures, the right outcomes, the right drivers in place for your organization. And that's it.
Thank you, Ramona and Rachel. I think we have time for some questions. I don't know if there are questions. No? So thank you for your talk. So only a reminder, so please rate the session in the Google app, and the closing keynote at 4 p.m. So yeah, joining us. So thank you so much.